Welcome to our donut modeling tutorial. I'll guide you step by step as we build a classic 3D glazed donut, and by the end, it'll look good enough to eat. Alright, let's start from a brand new scene. First things first, delete the default cube. Select it, press delete, and just like that, it's gone. Every Blender project starts this way. At this point, deleting the cube is basically a rite of passage. Now let's add our base shape. Press Shift-A, go to Mesh, and choose Torus. And honestly, this is already doing most of the work for us. A torus carries the core structure of a donut. Once it appears, scroll your mouse wheel to zoom in and take a closer look. You should see something that already reads as a donut. It's not finished yet, but the foundation is solid. Right after adding the torus, look down to the lower left corner of your screen. You'll see the operator panel. This is where we can adjust the object's parameters while the mesh is still live. Here, we can control the overall size, the thickness, and the resolution. Just keep in mind, these options are only available immediately after adding the object. If you click away or deselect it, the panel disappears. If that happens, press F9 to bring it back. Now let's shape this into something like a proper donut. Set the major radius to 1. This controls the overall scale. Then, set the minor radius to 0.4. This defines the thickness of the ring. You should immediately see the form becoming more convincing. Now, quick workflow note. This is something a lot of beginners miss. Increasing the major and minor segments increases resolution. More segments mean smoother curves, but they also mean more geometry. And more geometry means more processing power, which can slow things down and make the model harder to manage. So instead of pushing the values too high, let's be intentional. Set the major segments to 48. That gives us a clean, circular shape. Then set the minor segments to 16. That's enough detail to hold the shape without making the mesh unnecessarily dense. This gives you a really nice balance, smooth and professional, but still lightweight and easy to work with. We don't need extreme resolution here anyway, because later we'll rely on modifiers to handle smoothing in a much smarter way. Once you're happy with the proportions, click anywhere outside the panel to confirm. And just like that, you've built the foundation of your donut. Alright, now let's refine the surface. If you look closely, the shading still feels a little faceted. Not incorrect, just not polished yet. With the torus selected, right-click and choose Shade Smooth. This doesn't change the geometry. It only adjusts how light transitions across the surface. But visually, it makes a huge difference. Instantly, the donut feels softer, like baked dough instead of carved stone. Now, while Shade Smooth improves the appearance, it doesn't actually add geometry. To enhance the real surface quality, we'll use a modifier. Head over to the Properties panel on the right. Open the Modifiers tab. Click Add Modifier. Under the Generate section, choose Subdivision Surface. This modifier increases the polygon count while smoothing the overall form. It's one of the most important tools in hard surface and organic modeling. It lets you work low poly while presenting a high-quality result. In the subdivision settings, set the viewport level to 1, or 2 if your system handles it comfortably. This keeps your workflow responsive. Then set the render level to 2 so we get a cleaner result in the final image. The viewport shows a simplified version, so it stays easy to edit. If you temporarily reduce the viewport level to 0, you'll see the original base mesh underneath. Then increase it again, and watch how Blender redistributes geometry evenly across the surface. This is a professional workflow habit. Keep your mesh light while modeling, and let modifiers handle the refinement. It keeps you fast, and it keeps your scene efficient. Alright? Now we have a clean, smooth donut base, ready for the next step. But, let's be honest, right now it looks too perfect. Real donuts aren't perfect. They settle under gravity. They expand unevenly. They have subtle irregularities that make them real. So now, we're going to introduce some natural variation. At the moment, we're in object mode. You can see that in the top left corner. Click the drop-down, or simply press Tab to switch into edit mode. Now you're seeing the actual structure: vertices, edges, and faces, the building blocks of the form. Turn on proportional editing by pressing O, or by clicking the small circle icon in the top toolbar. This tool allows you to move a single vertex while smoothly influencing the surrounding geometry. It's essential for organic modeling. And yes, a donut absolutely counts as organic. Select a vertex, press G to move it slightly. You'll notice a circular fall-off area appear around it. That circle represents the influence radius. Scroll your mouse wheel to adjust the size. You can also use page up and page down. If you're on a Mac and those keys aren't available, you can remap them later in the key map settings. But the concept is simple. A larger circle creates broader, softer adjustments. A smaller circle gives you tighter, more localized control. Now start gently pushing and pulling points, some outward, some inward, very subtle movements, as if you're shaping soft dough and letting it relax into something less manufactured. There's no rush here. These micro adjustments may seem insignificant on their own, but together, they're what shift the donut from digital to believable. Watch how the surface responds, how the silhouette starts to break away from that mechanical smoothness. As you move around the donut, keep adjusting the influence radius based on the kind of variation you want. Sometimes smaller for controlled detail, sometimes wider for broader shape shifts. Here, I'll push this area down slightly. Move around the model. Select a vertex, press G, then Z, just enough to introduce a soft unevenness. Maybe this vertex comes up a bit, just enough to break symmetry. Let's rotate to a side view. Take a central point, press G, then Z, and slowly lift it. Watch the curve adjust. Maybe this one goes down. And this one too, slightly lower. Then bring this one up very subtly. All right, let's check the bottom. Select a point, press G, then Z, and pull it down slightly, just enough to suggest the dough compressed under its own weight. Rotate around the model. Keep evaluating the surface. I will lift this area slightly. Now let's refine the inner ring. Right now it's too perfectly circular. In reality, that inner edge would never be mathematically precise. Select a vertex and pull it outward. Actually, inward feels better here. Yes, that breaks the symmetry more naturally. And this section, just a subtle inward adjustment. Don't overdo it. This isn't a technical checklist. It's observation. It's sensitivity to form. You're simply breaking the perfection, removing the artificial symmetry. Think about a real donut, slightly uneven, a bit compressed, organic. Try to recreate that impression as convincingly as possible. That's looking good. You can already see the difference. The form feels more relaxed, more believable. We've introduced variation from the top, the sides, the bottom, and along the inner ring. And now it has enough irregularity without becoming messy. That balance between control and imperfection, that's what gives the model character. To push the realism a little further, let's gently flatten the donut through the middle. Real donuts aren't perfectly round all the way around. They compress slightly as they rest and cook. Start by selecting a single vertex, then hold Alt and left-click on an inner edge loop to select the entire ring. Before we continue, turn off proportional editing. For this adjustment, we want clean, controlled scaling. Press S to scale and slowly bring the ring inward just a bit. You can hold Shift while scaling for finer control. We're not crushing the donut, just softening that perfectly circular profile. Even this subtle adjustment makes the form feel less synthetic and more physically believable. Now, here's a small real-world detail. When donuts are fried, they often develop a slight ridge near the top and bottom. This happens because the dough expands unevenly as it floats in hot oil. Let's recreate that. Press Ctrl-R to add a loop cut near the top edge. Hover until you see the preview line. Click to confirm, then scale that loop outward slightly. Repeat the process near the bottom edge. Press Ctrl R again, position the loop cut, confirm it, and scale it outward just a touch. To refine this further, press Z and switch to wireframe view. This makes it easier to see exactly what you're selecting. Make sure proportional editing is still off. Select the lower half of the donut, then press S and scale it slightly wider than the top. This creates a heavier base, a subtle indication of gravity. Next, select the top half. Slowly scale it inward just a little. Now the donut has a soft dome shape instead of a mechanically even ring. Take a step back and evaluate the form. The donut base is finished. It's no longer mathematically perfect, and that's exactly why it looks real. Now it's time to build the glaze. Instead of creating a new mesh from scratch, we will duplicate the donut. The reason is simple. The glaze follows the same overall form. Go back to Object Mode. Select the donut, press Shift-D to duplicate, then right-click or press Escape to leave it in the exact same position. Visually, nothing changes, and that's expected. Now let's organize the scene. In the outliner, rename the original object Donut. Rename the duplicate Glaze. It may seem minor, but naming objects early prevents confusion later. In small scenes, you can sometimes get away without naming, but in professional workflows, especially larger projects, organization matters. Good habits scale. Now select the glaze object and enter Edit mode. Since glaze only sits on top of the donut, we don't need the lower half of this mesh. Press Z and switch to wireframe view again. Wireframe allows you to see through the geometry, which makes selection more precise. Switch to a side view using the gizmo. Click the X-axis so you're looking directly at the donut from the side. Now, select all the bottom vertices, everything below the midpoint. Once selected, press X or Delete and choose Vertices. Press Z to return to solid view, then go back to object mode. You'll likely notice some flickering where the glaze overlaps the donut. That shimmering effect is called Z-fighting. It happens when two surfaces occupy the same space without thickness separating them. So let's fix that. With the glaze selected, go to the Modifiers tab and add a Solidify modifier. Set the offset to 1 so the thickness expands outward. If it moves inward instead, just set it to -1. Now slowly increase the thickness value. Watch the edge carefully as you adjust it. You want it to feel like real icing, soft, slightly heavy, resting on top of the dough, not paint, and definitely not armor. Once the glaze clearly sits above the donut with believable thickness, you're in the right range. Alright, now we have icing on the donut. But if you look closely at the edge, it still feels stiff. Real glaze doesn't stop with a clean, sharp line. It softens, it melts, it slowly drips downward under gravity. So let's build those drips. With the glaze selected, enter Edit mode. In the modifier stack, find the Solidify modifier. Enable the small display icon next to it so you can see the thickness clearly while editing. This just makes the process more comfortable. If you grab a vertex now and pull it downward, you'll notice it can intersect the donut. To prevent that, turn on snapping from the top toolbar. Set the snap type to Face and enable Project Individual Elements. Now, as you move vertices, the glaze will stay in contact with the donut surface instead of floating or cutting through it. If you try stretching the edge right now and it looks sharp or faceted, that's a sign the mesh doesn't have enough geometry. So before shaping the drips, we need more resolution. Switch back to Object mode. In the modifier stack, locate the Subdivision Surface modifier. Open the drop-down and choose Apply. This permanently adds geometry to the mesh, giving us enough density for smooth, flowing drips. Once applied, go back into Edit mode. You'll see there are now many more faces available. That's exactly what we need for soft deformation. Now, one important thing to watch. If proportional editing is on and the influence radius is too large, when you pull one vertex down, the opposite side of the glaze may move too. That's not realistic. Glaze doesn't pull through solid dough. To control this, we'll temporarily isolate the area we're editing. Switch to top view using the gizmo. Zoom toward the glaze edge. Hold Alt and left-click to select the bottom edge loop. To expand the selection upward, hold Shift-Alt and click the next loop. Continue upward until the lower section is selected, then press H to hide it. Now only the visible section remains active, so your edits stay controlled. Make sure proportional editing is enabled. Select a vertex along the bottom edge, press G, and gently pull it downward. As you do this, think about gravity. Some drips stretch longer, others barely move. Adjust the influence radius with your mouse wheel as you work. Move slowly around the donut. Select a vertex. Pull it down. Then move to another. Don't drag randomly. Instead, visualize where glaze would naturally gather, where it would hesitate, and where it would finally fall. Some sections should hang noticeably lower. Others should just soften along the rim. Work your way around the donut, building an uneven dripping pattern. Take your time. Irregularity is what makes this believable. Each drip should feel like it formed under its own weight. For example, I will take this vertex, press G, then Z, and intentionally pull it downward. That creates a wider, heavier drip. Now this one, with a slightly larger influence radius, let it fall a bit more. You can feel the difference in thickness. Next, use a smaller radius for a tighter, thinner drip. Vary the size, vary the length. Some drips should be wide and stretch lower. Others should stay shorter, almost held in place by surface tension. Just like real glaze, some drips merge slightly with their neighbors. Others remain separate. Keep moving around the donut, slowly shaping the edge. Here, I might also push a few points upward slightly. That introduces a soft wave along the rim. Avoid straight horizontal edges. Avoid anything that looks patterned. Lift some vertices subtly. Let the edge feel fluid, as if the glaze is stretching gently across the surface. Some drips cling close to the top, barely affected by gravity. Others stretch past the edge and pull downward more dramatically. Step by step, let the glaze start to feel alive, organic, weighted, naturally formed. Once the shorter drips is done, we can introduce a few longer, more dramatic ones. Start by selecting a single vertex along the edge, then shift-select the neighboring vertices beside it. Press E to extrude them downward. At first, it may look a little rough, almost blocky. That's normal. To smooth it out, add another subdivision surface modifier. If the edge still feels slightly sharp, increase the viewport level in the subdivision modifier to 2. That extra subdivision gives the glaze a creamier, more melted appearance. Now, there's one more detail to refine. If you look closely at the edge, some areas may appear to float slightly above the donut surface. To fix that, select the glaze object, go to the Solidify modifier, and under Edge Data, increase Crease Inner to 1. This tightens the inner edge, so the glaze hugs the donut more convincingly instead of hovering. Now let's shape the longer drip trails. Select a group of neighboring vertices. Take a moment, make sure they flow together naturally. Press E to extrude and pull them downward slowly. Place them where gravity would realistically stop the drip. Then scale the new edge slightly to keep it rounded and soft. Repeat the process in another area. I'm going to carefully select these neighboring vertices. I will extrude them downward, slowly, and then guide them into place, right where I want this drip trail to end. I scale it down slightly to keep the tip of the drip rounded. Rotate around the model, adding variation where it feels right. I will select a new group of vertices nearby. then extrude downward. I will scale it down just a little. That small adjustment keeps everything smooth and organic. Select a group of neighboring vertices. Press E to extrude and pull them downward slowly. Extrude in stages, adjusting as you go. You can scale with or without proportional editing, depending on the shape you're aiming for. Adjust the influence radius with your mouse wheel as you work. Move slowly around the donut. For longer drips, there's something important to keep in mind. If you extrude too far in a single movement, the geometry can stretch and become too thin at the bottom. Instead, extrude in stages. 2, sometimes 3 smaller extrusions. Pause briefly between each step, adjusting as you go. You can scale with or without proportional editing. Introduce subtle variation. Let gravity guide the form. Some drips should extend farther down. Some should be medium length. Others should remain subtle. For longer drips, use 3-step extrusion. For medium drips, 2 steps. For small accents, a single extrusion is enough. This layered variation prevents repetition and keeps the glaze feeling organic. Select adjacent vertices. Press E, then Z, and extrude downward. Scale slightly to keep the edge rounded. Turn on proportional editing by pressing O. I will scale it down just a little. Keep evaluating the surface. Select adjacent vertices and extrude downward. Place intentionally. Scale slightly to keep the edge rounded. Select a group of neighboring vertices and extrude downward. Scale slightly to keep the edge rounded. Select adjacent vertices. Press E, then Z, and extrude downward. Extrude 3 smaller extrusions. Scale slightly to keep the edge rounded. I will scale it down just a little. Nothing should feel mechanical or repeated. I will lift this area slightly. All right, one more area to refine. Don't forget the inner ring. Glaze also flows inward toward the hole. Press Alt, then H to reveal the hidden mesh. Select a vertex along the inner edge. Press G and pull it downward slightly to begin forming a soft inner drip. Maybe lift a nearby vertex just a bit, introducing gentle variation. Treat this area the same way as the outer edge. As long as nothing blocks it, glaze flows downward naturally. Select a vertex, press G to move it slightly. Scroll your mouse wheel to adjust the size. For longer inner drips, select adjacent vertices. Press E, then Z, and extrude downward. Select, extrude, place intentionally. And just like before, introduce subtle variation. Let gravity guide the form. Select adjacent vertices. Press E, then Z, and extrude downward. Select, extrude, place intentionally. Scale slightly to keep the edge rounded. You can scale with or without proportional editing, depending on the shape you're aiming for. Select, press G to move it slightly. Select adjacent vertices. Press E, then Z, and extrude downward. Select, extrude, place intentionally. Scale slightly to keep the edge rounded. You can scale with or without proportional editing. And just like before, introduce subtle variation. Here, maybe this vertex comes up a bit. Once you're finished, pause and evaluate the silhouette. The glaze now feels uneven, layered, and visually interesting, like real icing slowly sliding down a freshly baked donut. That's looking really strong. In the next part, we will continue refining the model and push it closer to the final form. Whenever you're ready, I will see you in the next video.